Hello friends, in this video we discuss about electric flux. First of all, what is the electric flux? Counting of electric field line. Electric field line passing through given cross section area. Through given cross section area. So flux directly proportional to electric field, flux directly proportional to area, flux directly proportional to cos theta. So flux equal to EA cos theta. So flux equal to E vector dot A vector. If this is of area A and the electric field is passing through area A, then what is the flux? If this is theta, break this electric field into its component. This is E cos theta and this is E sin theta. So what is the flux? Flux equal to EA cos theta. Here the number of electric field line is E cos theta passing through area A. So this is EA cos theta. Now this flux, this is a scalar quantity and unit equal to Newton meter square per coulomb. Now if electric field is present in x-axis, y-axis and z-axis, then how we calculate electric flux? Then Ex I cap plus Ey j cap plus Ez k cap dot product of Ax I cap plus Ay j cap plus Az k cap. So flux equal to dot product of Ex I cap and Ay I cap. Ax cos theta is the angle between Ex I cap and Axy I cap is 0 degree plus dot product of Ey j cap and Ay j cap is Ay and cos theta is the angle between Ay j cap and Ey j cap is 0 degree plus dot product of Az k cap Az k cap Az cos theta is the angle between Ez k cap and Az k cap is 0 degree. So flux equal to Ex Ax into 1 plus Ay into 1 plus Az into 1. So flux equal to Ex Ax plus Ay plus Az. Now if E is variable, then so we take a small flux d phi equal to E vector dot A vector and we integrate this so that total flux can be calculated. Total flux equal to integration of E vector dot A vector. Now we discuss about Gauss law. What is Gauss law? Flux passing through any closed surface is Q divided by epsilon naught, where Q is enclosed charge and this flux does not depend on outside charge. So flux equal to Q inside divided by epsilon naught. Now proof of Gauss law. Let us consider a sphere of radius capital R and charge Q is present at the center of a sphere. Now consider a small area element on the surface of a sphere. Now we have to find flux through the closed surface. So flux through this area element is defined equal to E vector dot dA vector. We integrate this to find the total flux passing through the sphere. Total flux equal to integration of E dot dA vector flux equal to integration of E. Here electric field is KQ divided by capital R square dA cos theta is the angle between the electric field and area vector, which is 0 degree. Flux equal to KQ divided by R square integration of dA. So flux equal to KQ divided by R square integration of dA equal to 4 pi capital R square. This cut is flux equal to Q into 4 pi. We can write K as 4 pi epsilon naught. This 4 pi cut this 4 pi, and flux equal to Q divided by epsilon naught. And Q is the charge present inside the sphere. So Q inside divided by epsilon naught. This is the flux through any closed surface equal to Q inside divided by epsilon naught. Now we know more about flux. Flux does not depend upon location of enclosed charge. Flux does not depend upon size and shape of enclosed surface. Flux does not depend on charge outside the enclosed surface. Thank you.